In section 10.6, we're going to take a look on how to solve radical equations. Now, a radical equation is an equation that has a radical expression in it. So, for example, square root of x plus 1 equals 7. That's a radical expression because it has a radical in it. Cube root of x minus 2 equals 17. That's another one. Or I can have a square root of x plus 5 equals the square root of x minus 1. That's another example of a radical expression. Actually, these are all radical equations because every one of those has equal sign in it. Now, in radical equations, what we want to do is we actually want to solve these equations. That means we want to solve for the unknown, something that we haven't done yet. Okay? Now, the only, if you call it a principle, the only idea in the section that we have that's new, we haven't seen before, is called the principle of powers. Okay, this principle of powers goes, it's very simple. If A equals B, if two things are equal, no, that calendar popped up. If A is equal to B, then we can actually raise both sides of that equation to a power. That's what this says. Okay? Now, notice that this expression in the form of if, then. That means if the supposition, this is the supposition. If the supposition of this statement is true, then the implication, or actually the conclusion of this would be true. In other words, if two things are equal, you square them, cube them, raise them to any power, they'll still be equal. However, going in this direction, this expression may not work. Okay, so we cannot go in that direction. So for example, check this out. We all agree that negative let's say 5 squared is equal to 5 squared, isn't it? And in fact, let me use different colors here for these two numbers. So you see I have two different numbers, right? So B is 5 and negative 5 would be A. Okay, now I'm going again from right to left and it's not going to work. So I already have them in the form of powers. Then this does not mean that negative 5 would be equal to 5, would it? And that's B, and of course negative 5 is the A, right? That doesn't make sense. They're not. So again, just to go to show you that this expression, the principle of powers, only works from left to right, and it may or may not work from right to left. Okay, now it's precisely due to this property or principle that anytime we have radical equations, we always check the solution. The reason is because if we raise an equation both sides to a power, we may introduce extraneous or additional solutions that will not work in the equation. Okay, so there you go. That's all we have in this section, the principle of powers. Now, with that, let's actually go and take a look at some of these homework problems. Okay, so our first homework problem we're gonna look, sorry about that, we're gonna look at exercise number 10 in this section. In number 10, we have square root of 7x minus 3 equals 5. Okay, so what I want to do is, because we have a square root here, so we're going to raise both sides to a power, and usually you raise it to the power of the index. Remember, the index is 2 here. If it's not, the written is 2. With the square roots, the index is 2. So that means I'm going to square both sides. So the index pretty much tells you what exponent to raise both sides to what power. Now on the left side, we're just going to get 7x minus 3. Taking the root and squaring it, it's an undoing effect. So what happens is we get the radicand back to the right, whatever 5 squared is. And this becomes a simple linear equation, doesn't it? I'm going to isolate x, add 3 to both sides, and divide both sides by 7. X is 4. Now, at this point, personally, I call these solutions at this point for any equation. I think of these personally as what I call potential solution. That means it has a potential to become the solution to the equation. So how does it become the solution? I need to check. So let's run a check and see if it works. If it does, then it becomes the solution to the equation. X is 4, so I'm going to replace x right here. X with 4. Okay. And let me remove my marks. Okay, so that's 7 times 4 minus 3 equals, I'm going to put a question mark here. Right, because I'm checking, I'm verifying, it may not work. Hopefully it works. So, now in the radicand, 7 times 4, 28 minus 3 is 25. Will that equal to 5? Yes, because root 25 is 5. 5 is equal to 5, and I'm going to put a check in here. There you have it. Okay, so the solution is x equals 4. See how simple that was? Number 10. Let's take a look at, for example, number 20. In number 20, something of a higher index, higher root. This time the 4th root of t plus 5 is equal to 2. So remember, we always raise to the power of the index, in this case 4 and 4. Okay, so on the left side, we're just going to lose the radical sign, that's t plus 5. And on the right side, we got 2 to the 4th. That's 2 by 2 by 2 by 2. 16. Now it's easy to work with, right? Let's subtract 5 from both sides, and we get t is 11. It is a potential solution, right? At this point, until we verify it. So here is our check. So I'm going to go with the 4th root of t, but then t was what, 11? And then do plus 5. Will it equal to 2? Now, 11 plus 5 is 16. The 4th root of 16 is indeed 2, right? Because 2 by 2 by 2 by 2 is 16. So the 4th root of 16, it's like, where did the 16 come from? It was raised, or it was multiplied by itself 4 times before it became 16. So 11 is the solution to this equation. Number 20. Let's take a look at something different. Let's take a look at number 28, for example. Number 28, we have x to 1/4 minus 2 equals 1. Now, x to 1/4, this is a rational exponent. One of the sections earlier in chapter 10, we looked at the relationship between radicals and rational exponents. Let me put that relationship more specifically. X to 1 over n is the nth root of x. Okay, so x to 1/4, in other words, that means the 4th root of x. Minus 2 is 1. Now, I could raise both sides to the 4th power, right? But we always solve for radical before you do it, because otherwise, if you don't, you're not going to do this most likely correctly. Just to kind of show you real quick what I mean, you not correctly is this. There you go. There's nothing wrong with this. I can raise both sides to 4th power at any time, but it's easier to isolate for the radical first, then raise it to a power, because if I raise this to a power, I'm going to actually end up with 5 terms. Remember, this is to the 4th power, so that means I got to foil this and multiply the binomial by itself, what, 1, 2, 3, 4 times, right? There. Which I'm not going to do that. That's why we don't want to raise both sides to the fourth power right away. So what do we want to do? We want to isolate the radical. That means add 2 to both sides. Now, let's raise both sides. See, now that the radical is isolated, we can raise it to a power. And what power do we want to raise it to? You guessed it correctly, fourth power. Okay, so on the left side, fourth root of something to the fourth power, you get the radicand back. And 3 to the fourth power is 81. Right, 3 by 3, 9 by 3, 27 by 3, 81. Again, this is a proposed solution at this point. Let's try it. And by the way, we always try in the original equation, not the ones that are worked in between, because we are manipulating them. So they should work in the original. So here's my check. I'm going to go with this version of x to 1/4. So is the fourth root of 81 minus 2 equal 1? Question mark, because I'm checking. Now, fourth root of 81, again, that's just going to be what? 3? That's 3 minus 2, which is 1. It checks. So there we have a solution. Now, let's take a look at, it's working, so how come we need to check, right? Let's take a look at number 30. In number 30, we have square root of a is equal to -1. So the radical is already isolated, and I'm going to square both sides. Now on the right side, I'm going to get 1. Oops, sorry, don't want to use that color. On the right side, I'm going to use 1. -1 squared is 1. On the left side, square root of a squared is just a. So there you go. We have a potential solution. A is 1. Now let's check it. See if it works. Square root of 1 equals -1. Now square root of 1 is 1. 1 does not equal -1. You see that? It didn't work. So the only potential solution, a equal 1, is the one that did not work. So we're just going to discard it, and for this one we're going to say no solution in this one. And usually in this book, I believe that's how they show no solutions, or you can just write it as no solution. Let's take a look at another one. Let's take a look at number 40. In number 40, we have 2t minus 7 equals square root of 3t minus 12. Okay, we want to solve this one. Now again, we're going to square both sides because this is a square root. True? Square and squared. Remember, you square square root, you lose the radical. That's 2t minus 7. And the right is 3t minus 12. Now next we're going to subtract 2t from both sides. Okay. And subtract 2t from both sides. We get -7 is 3t minus 2t is t minus 12. And then we're going to add 12 to both sides. That's 12 minus 7 equals t, right? Adding 12 to both sides. 12 here, 12 there. Those add to 0. 12 minus 7 is 5, and t is potentially 5, right? Let's check to make sure it works. So here's our check. We have square root of 2t, that would be 2 times 5 minus 7. Will that equal to square root of 3t minus 12? Now 2 times 5, 10 minus 7, that's 3. On the right side, 15 minus 12 is also 3. They look the same, don't they? Root 3 equal root 3, that's true. It checks. So that is a good working solution. Okay. So there you have it. Again, another short, brief section. Hopefully you're able to follow everything here all right. And with this, we are done now with section 10.6 of this chapter.